teacher. So this will be my presentation about the Euler's method. So we'll get into it. So basically, the Euler method is this: your dy over dx is equal to f bracket x and y. So basically, the Euler method is the first order numerical technique that used to approximate a numerical solution to the ordinary differential equation. So basically, you will have this method: your yn plus 1 is equal to your yn plus h times your function, then other xn and yn. And then your h will actually be your step size. Your y will be like a known number. So let's just say we'll come to this, which is your x, y, and your dy over dx. So 0 will be like what we say. We'll put 0 as your x and 1 as your y. And then dy dx is 1. So when we go down, it will be adding by 1, which is equal to your step sizes. So your y will initially become x and y. You just add 1 also. You add 1 and then you times the dy dx outcome from the previous. Then you can get this. Then you add 1, then your number will keep going down. So your rough estimation of your formula would for your Euler graph, your actual one will actually be like a smooth line, while your Euler is just an approximation of the graph. So it'll be near, but it's not exact answer. So we'll head over to the Excel sheet, which is this. So this Excel sheet actually is for our formula, which is actually this formula. So they're asking us to find dy over dx is equal to x squared plus 1 over y. And they're given that y is equal to 0, find it 0 is 1. So this is how I do it. And then my step size I just use 0.1. So it's from 0, and it's 1 and 1. So basically for your f, x, and y, you're actually just using we are using this formula, which is x squared. My x squared is this, and then plus 1, then that over d4, which is my y. And then you just repeat all of it until you get x is equal to 1. And then your answer would be this. Your answer will be y, because you're trying to find y. So which is, for the normal answer, it will be this. So we just write Euler method. Euler method is 1.911. Okay. After that, we'll go back to the... So this is actually how I solve for the real method. So we'll just put dy over dx, which is the formula. Then that we sub it, you cross multiply. Then you just get y dy. Then you put y one side and x one side. And that you integrate both, and you get this value. After that, just make sure it become you substitute it. So which is y over 2x 3 over 3 plus 2x plus c. And then you just sub in x is equal to 0 and y is equal to 1. Then you get your c answer, which is 1. Then you sub the c back into it. So it will be y is equal to 2 bracket 1 3 plus 2 bracket 1 then plus 1 3. So we just have to sub x is equal to 1 and your c is equal to 1, which is you get this. You get 1.915 as your actual answer. So your 1.995. So basically your margin of error, it will be this. Your margin of error will actually be your real answer minus your y number. So this is your margin of error, 0.0036249. So basically in the end, your Euler method wouldn't be like a proper, it's just a rough estimate of like how the graph and your number would be. So, and the smaller the step size you have, then you will have a smaller margin of error. The bigger of your step size, the larger your margin of error would be from the real answer. So that's all. Thank you.